Hey everybody, your Friendly Math Tutor here with episode 2 of our SAT mini course, where each class we dissect an SAT strategy that'll help you achieve your best score on the upcoming SAT. Before we get to today's strategy, let's review last episode's strategy of plugging in answer choices by going over the closer problem from episode 1. So just to review, that problem was College Board Practice Test 5, Section 4, number 13, and it was this system of inequalities, y is less than or equal to 3x plus 1, and x minus y is greater than 1. The question says, which of the following ordered pairs, x comma y, satisfies the system of inequalities above? Now, we're not going to actually do the school way, but let's just talk about it, and let's just talk about how annoying, if the lack of a better word, it would be. So if we were to graph a system of inequalities, what we would need in school is we would need some graph paper, we would need a ruler, we would have to graph the first boundary line, then we would either shade above or below the line based on some test point, or we could use this inequality. We'd have to graph a solid line because of it's inclusive. Then with the second one, we'd have to, again, graph the boundary line, probably rearrange a little bit, pick a test point, shade above or below. This one we'd have to graph a dashed line. All right, and then, if we were able to achieve or accomplish all of that without graph paper or a ruler, we'd then have to see which of these answer choices would fit in our region that had both shaded areas in it. Sounds a bit complicated, right? Not exactly complicated mathematically, really, just a lot of work that is unnecessary, and especially since you're not going to have graph paper or a ruler when you take the SAT. So let's just say, okay, that way is going to take a while, and if anybody wants to try it on their own and try to prove me wrong, and you want to do it in 20 seconds, then feel free, leave some comments below. I'd love it if you were able to do that. But let's talk about a more realistic way to do this problem, and that is just simply what we were reviewing last episode, which is to just plug in your answer choices. So let me rewrite the inequalities here. Y is less than or equal to 3x plus 1, and x minus y is greater than 1. So if you're going to plug in all your answer choices to a system, you want to do it one of two ways. You're either going to pick an answer choice and plug it into both of them, all right? And then if they both work, then that's the answer. If either one doesn't, then that's not the answer. I could go through this for, obviously, 3 of 4 answer choices at most. Or we could pick about one of them and just plug it into one of them, and if it doesn't work, then we eliminate it. If it does, then we keep it alive, and we check the other ones. And we can probably run through them a little more quickly because we're going to keep plugging into the same one. So I'm going to choose to do it that way. So I'm going to run through, and then I'm going to look at these two inequalities. Me personally, I believe that this second inequality is easier to plug into. Standard form tends to be easier to plug into because the x's and y's are on the same side. So all I have to do is plug every answer choice into this one. All right. If I have multiple answers that still work, then I'll use those to plug into the first equation. So I'm going to go with A. And another reason that I also find standard form easier for students to do is because in slope-intercept form, the y comes first. And a lot of times our brain wants to plug in the coordinate that comes first. But we know it's backwards, right? Because y comes first here, but in the coordinate plane, it's x comma y. Whereas in standard form, the x comes before the y, so I see a lot less mistakes. So I like plugging into standard form, and I like my students to do that too. All right. So I plug in -2, -1, and so I'm checking answer choice A, and I get -2 minus -1 is greater than 1. This minus and negative becomes a plus, and -2 plus 1 is -1 is definitely not greater than 1. So I have eliminated that answer choice because it doesn't work for the second one, so it doesn't matter if it works for the first one. Now I go to B, and I have -1 minus 3 is greater than 1. Well, negative 1 minus 3 is negative 4, and negative 4 is definitely not greater than 1. So that one's gone. And then I have to check C, and I got 1 minus 5 is greater than 1. 1 minus 5 is also negative 4, and negative 4 is definitely not greater than 1. So I have just eliminated 3 answers very quickly by plugging in. And so that means that D must be the answer. If you have a little bit of extra time, depending on how the test is going, if you feel like at this point in the test, oh, I have a little bit of extra time, you can certainly check that answer, and you'll see that it works for both of them. Kind of, make sure that you didn't make a silly mistake before. But honestly, if you're really practicing and all you're doing is plugging in numbers, if the first 3 don't work, then the 4th one is going to work. So therefore, we get answer choice D, and that is it, and we can move on to today's lesson. All right, let's move on to today's topic, which is going to be pick your own values. What this is going to be is a lot of times when you see there are multiple variables in the problem, or you'll see this equivalent expressions, or something that seems way kind of too challenging to manipulate, where it would be a lot easier if there were actual numbers there. You can pick your own values and plug them in and kind of work the problem out, and then plug those same values into the answer choices, and that way we'll be able to find the answer. So a couple things to keep note of. Always keep track of your numbers. If you're making A equal to 5 and B equal to 6, write those down so that you can remember what numbers you pick. You want to try to keep too many things in your head. You want to try to choose the easiest possible numbers, but that can change. On some problems, 0 is a wonderful number to pick, and in other problems, 0 is going to be the worst number to pick. We will talk about that, and again, doing more of these, you'll get experience as to which are good numbers to pick on which problem. These are not so great for just solving any kind of equations or systems of equations. For that, you would refer back to episode 1, because you would want to either do it the school way, or you would want to check your answer choices, because when you're solving equations, there is just one definitive answer typically. So you don't want to just pick your own values. You're not just going to make up values. So again, we're looking for multiple variables or the words equivalent expressions. You want to realize that the numbers that you pick, you're eliminating answers. So if you get answer A that works, don't just automatically pick that. You really got to make sure that B, C, and D don't work. If 2 of your answers still work, then you've got to go back and pick new values, which can be quite tedious. So hopefully the better that we get at this, we can stay away from picking those values that will just give us multiple answers. But it happens. It happens all the time. So it's not a problem. It still can be more, it still can be done more quickly than the school way, essentially. All right. So let's take a look at our opener problem for today. This is College Board Practice Test 1, Section 3, number 14. If 3x minus y equals 12, what is the value of 8 to the x over 2 to the y? And we have 4 answer choices, and our answer choice D is the daunting. The value cannot be determined from the information given. This is always such a difficult thing to choose. But let's see what happens. Hopefully we do the problem, we get one of the first 3 answer choices, and if we're confident that we don't, then we can pick D. So let's take a look at the school way first. And what we would probably need to do here, in reality, this problem is a little bit different than anything you would even see in school. But let's look at one way that we could do this using the substitution method. So what I would do is I would try to isolate this y. So 3x equals 12 plus y. And then I would want to move the 12 to the other side by subtracting. So I get 3x minus 12 equals y. And then I'm going to take that and I'm going to plug it in to my expression. And therefore, that gives me 8 to the x over 2. Instead of y, I'm going to think of it as 3x minus 12. And then we have to think about our exponent rules. Well, when I divide, I need to have the same base. And these are not the same base, but they both come from the same base. So 8 is a power of 2. So what I can do is I can replace 8 with 2 cubed. And then I have 2 to the 3x minus 12. And then this gives me 2 to the 3x over 2 to the 3x minus 12. And then finally, when I divide and I have the same base, what I'm going to do is I'm going to subtract my exponents. So I end up with 2 to the 3x minus 3x minus 12. And finally, I get 3x, I distribute, and 3x minus 3x is gone, and negative 12 is 12, so I get 2 to the 12, which is answer choice A. That is a bit long, all right? That's a little longer than we would like to take on your typical SAT problem. So what I would do is kind of avoid doing it this way, all right? This way is going to take some time. So now let's take a look at your Friendly Math Tutor way. So what we want to do is, again, our topic today is pick your own values. So we're going to pick the values that we want that make this problem a lot easier. So if we start out with our 3x minus y equals 12, we want to pick 2 values, right? But we can't just make up any values that we want. They have to fit this equation. So what I find really easy is, well, what if I made x equal to 4? Because that's 3 times 4 would make 12. That would make y equal to 0. Then we're just going to take those and we're going to plug it into the expression that they asked us to evaluate. All right, so a lot of times they give us an equation, and then this is an expression. So earlier I said this method doesn't work good for systems of equations. This is not a system because this isn't even an equation. So when they ask you for an expression, this is the perfect opportunity to pick your own values and then just plug them into the expression. So I've got 8 to the 4th over 2 to the 0, which is just 8 to the 4th, because 2 to the 0 is 1. Anything to the 0 power is 1. So therefore, I've got 8 to the 4th. Well, that answer is not there, but it is an answer, so it certainly can be determined. It's definitely not 8 squared, so it's either A or B, but still, we can keep going. And we're going to use something similar that we used in the school way, is we are going to think of 8 as 2 cubed. So 8 is 2 to the 3rd, that's raised to the 4th. We've got another exponent law, 2 to the 3rd to the 4th is just 2 to the 12th, which gives us answer A. All right, now we're moving on to the second problem. This one is College Board Practice Test 2, Section 3, number 15. It says the expression 5x minus 2 over x plus 3 is equivalent to which of the following? So here we've got our equivalent expression. Let's take a look at the school way, which actually isn't really that time-consuming. And what we can do is, if we're actually dividing these, we can do some long division. And then what we're doing is we're asking ourselves, how many times does x go into 5x? That is 5 times. And then we multiply back. So 5 times x is 5x. 5 times 3 is 15. And then we simply subtract. That makes the 5x's go away. And negative 2 minus 15 is negative 17. So what this means is that we have a quotient of 5 and a remainder of negative 17. So that means this expression could be written as 5 minus the remainder over the original denominator, which is D. You could also use synthetic division for this one to do the exact same work. I'm not going to get into that, but just know that the point of this problem is that the school way actually doesn't take that long. But I've worked with many, many students, and when they haven't done long division in a while with polynomials, many times they forget. And a lot of times I hear it all the time, it's just, oh, I don't remember how to do that. So the point of this problem is we were talking about this back in episode 1. Not always is it that the method, your friendly math tutor way method is going to be quicker, but it's going to be that thing that you can have in case you forget the concept from school. So the whole point of this problem is, well, this long division is something that you may have done for like a week and then you haven't done it in a year or two. All right. So let's say we forgot how to do that. There's a really simple way by picking your own values here that we can do this problem. So your friendly math tutor way would be this. And the one method is to always eliminate answers. This even applied last time to episode 1. You want to eliminate A and B because there is no way that you can just eliminate these x's. It wants an equivalent expression. These x's in this way are not going to just magically disappear. So A and B just don't make sense at all. So this is a great time to pick your own values because A and B are gone and you're down to C and D. So what we're going to do is we're going to pick any value that we want for x, all right? I am going to choose x equals 0. And what I'm going to do with it, I'm going to plug it into the expression that was given. So that's 5 times 0 minus 2 over 0 plus 3, which is equal to negative 2/3. Now, if the answer is truly equivalent to this expression, then plugging in 0 to that should give me the exact same answer. And what's beneficial is that we have now narrowed it down to C and D, so I only have to plug it into one of them. If it works for that one, it's the answer, and if it doesn't, it's the other answer. So what we're going to do is plug it into C. So 5 minus 2 over 0 plus 3, which equals 5 minus 2/3, which you may be able to see. How could you take 5 and subtract 2/3 and get negative 2/3? That just doesn't seem to make sense. But if you certainly want to see for yourself, 5 is the same thing as 15 over 3 minus 2 over 3. I hope now you believe me that that is 13 over 3, which is not negative 2/3. So we have now eliminated A and B for their just ridiculousness that X just is gone. And we have eliminated C because the number that we picked doesn't work, doesn't equal both of them. And D must be the answer. And you can certainly check if you replace X with 0, 5 minus 17 over 3 does in fact give you negative 2/3. All right. All right, now to our third problem. This one is College Board Practice Test 4, Section 3, number 6. If A minus B over B equals 3 over 7, which of the following must also be true? So this is kind of like equivalent expressions. It's more of equivalent equations. So we want to know when this equation is the same as any one of these. So one of these is just a different form of this. So if we take a look at the school way, again, this is another example where you don't actually exactly do this in school a lot, but you do learn about proportions and you certainly learn about something called cross multiplying. So we're going to use that concept from school. So when we cross multiply, so we have this A minus B over B equals 3 over 7. So we cross multiply and we have to remember to distribute. So we get 7A minus 7B equals 3B. And then what we can do is we can try to simplify. So I would add 7B to the other side. And we get 7A equals 10B. And then what we would want to do is we would want to go through all of our answer choices and we would cross multiply with each of these. So again, this is not a problem, honestly, that you would even do in school. I just kind of took the cross multiplying, from a concept you would learn in school to see how we would do it that way. But now it just becomes checking all of your answers. So it takes quite some time to then cross multiply all of these and then simplify and see which one gives you the same thing. So this is just not a very good problem for using cross multiplying from something, a concept that you would have learned in school. So let's, instead of go through all of that, let's just skip right to your Friendly Math Tutor way. So that means we're going to pick our own values. So if I have the equation a minus b over b equals 3 over 7, what I want to do is I want to pick a value for a and I want to pick a value for b. Well, I'm going to choose to pick a value for b first, because if you see that b is on the bottom and then 7 is on the bottom over here, it's really simple if I just make b equal to 7. And then if I imagine this b is now 7, some number minus 7 must give me 3, well, that number would be 10. So now I have picked my values. So as you can see, like these values could be anything that work for that problem. So the notion that we're just going to pick 0 every time doesn't really work. I highly doubt there was ever a time where you had been like, oh, I'm going to just pick 10 and 7 as the best numbers, right? But they work really well for this problem, and they may never work well for another problem again. So the idea is that you look at the problem and you pick the values that work for that problem. We're just looking at a general strategy of picking your own values. So now what I would do is I would just plug these into the answers. But this I can just do in my head. Look at A. This is like saying 10 over 7 equals negative 4 over 7. Well, that certainly can't be true. Would you look at this one? 10 over 7 equals 10 over 7. Well, I'm pretty sure that that's true, right? So B would be our answer. And you could certainly look at the other ones. 10 plus 7 over 7 can't be 10 over 7. And 10 minus 2 times 7 over 7 can't be negative 11 over 7. So really, really quickly, by just picking our own values, we can get the answer really fast, and we don't have to write down much at all. All right, let's move on. All right, now to problem number 4. This is College Board Practice Test 4, Section 4, number 29. If x is the average of m and 9, y is the average of 2m and 15, and z is the average of 3m and 18, what is the average of x, y, and z in terms of m? Quite a long problem, quite a difficult problem. It's number 29 on Section 4, and we know that Section 4 has 30 multiple choice, so number 29 is going to be one of your very, very difficult problems. So this one is my counter example to the Your Friendly Math Tutor way. So this one is, I believe, the school way works more quickly, which is, again, the whole point of this course is to know these strategies, but also to know when to apply them and then when not to apply them. So this is our case of when not to apply them. So let's take a look at the school way first. X is the average of m and 9. So right away, I'm going to write down that x equals m plus 9 over 2. That is simply because we know the average of two numbers is when you add them up and divide by 2. Y is the average of 2m plus, well, 2m and 15. So I'm going to write 2m plus 15 over 2. And finally, z is the average of 3m and 18. So I'm going to write 3m plus 18 over 2. And then they're asking for the average of x, y, and z in terms of m. So what I'm going to do is I'm simply just going to add up x, y, and z and divide by 3, because there is 3 values there. But instead of writing x, y, and z, I want them all in terms of m. So I'm simply just going to write m plus 9 over 2 plus 2m plus 15 over 2 plus 3m plus 18 over 2 all over 3. Now notice these fractions up top all have the same denominator, so I can add their numerators. So I'm going to add m, 2m, and 3m, and I'm going to get 6m. Then I'm going to add 9, 15, and 18, and I'm going to get 42. And then that is dividing by 2. and then dividing by 3. But dividing by 3 is the same as multiplying by 1/3. So I'm simply going to get 6m plus 42 over 6. And then I can take out a 6 in every one of these. So I'm left with n plus 7, which is B. All right? That's a school way. I know that seems like it took a while, but some of these problems are going to take some time. The key is on some of the other problems that you're using the strategies that we're teaching here, you're going to do those problems so quickly, you're going to kind of bank yourself some time to spend a little extra time on problems like this. But let's take a look at your Friendly Math Tutor way. It's not terrible. I still think this way is probably better, but hey, you got to decide for yourself. So I'm going to give you that way so that you can kind of figure that out on your own. All right, so our way is to pick your own values. So what we could do is just pick a value for m. And I'm going to just pick m equal to 0. So x is the average of 0 and 9. Well, the average of 0 and 9 is 0 plus 9 divided by 2, so that's going to give us 4.5. Y is the average of 2m, which is also 0, and 15, so that's 7.5. So again, 0 plus 15 divided by 2. This is a calculator section, so if you're not great with doing that math in your head, you certainly will have a calculator available for these problems. And Z is the average of 3m, which is 3 times 0, so 0 plus 18, and that is 9. So then we have to find the average of x, y, and z in terms of n. So that gives me 4.5 plus 7.5 plus 9 over 3, which is 4.5 and 7.5 is 12. 12 plus 9 is 21. 21 divided by 3 is 7. So now it's important to know that you're not looking for the answer of 7. You're looking for the answer that when you plug in 0 for m, you get 7. So if we look at A, 0 plus 6, not 7. B, 0 plus 7 is 7. C, 0 plus 14, no. D, 0 plus 21, no. So B is the only one that works. So I don't know. I mean, on second thought, I think maybe this way is quicker. It really depends. I think the whole point of this is not to just definitively say, oh, use these strategies on every problem, or to say, oh, the school way, don't ever do that, or always do the school way. It is a mixture. There are some of you watching this right now who are probably thinking, oh, well, this way, that's way quicker. What are you talking about? And others are watching this screaming like, no, 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 do it the school way. Why would I pick numbers? That's overthinking it, all right? You have to decide, all right? So I'm just kind of presenting both cases here. But I still, for some reason, would choose the school way. But some of you may, sometimes it's confusing for us when we have so many variables that this just simplifies the problem, all right? So again, think about what type of student you are. If you look at this problem and immediately your brain goes, oh, x is the average of m and 9. Oh, that just means x equals m plus 9 over 2. Well, then you should be doing it that way. But if you look at that and you are just like, I have no idea what I just read, I have just all these numbers, well, then you should be the type of person that would pick a nice, easy value, and now all those letters become numbers. And if I say find the average of 4.5, 7.5, and 9, you are going to know exactly what I'm talking about, as opposed to the average of Z is the average of 3M and 18. Some of you just that can be confusing, and there's nothing wrong with that. The key for you is to try to take the problem and make it easier. And picking your own values, I believe, is a way to make those types of problems easier. All right, so now to our closer problem. So for episode 2, we have a closer problem from College Board Practice Test 4, Section 4, number 25. And this question is, f of x equals 2x cubed plus 6x squared plus 4x, and g of x is x squared plus 3x plus 2. It says the polynomials f of x and g of x are defined above. Which of the following polynomials is divisible by 2x plus 3? Answer choice A is h of x equals f of x plus g of x. B is p of x equals f of x plus 3g of x. C is r of x equals 2f of x plus 3g of x. And D is s of x equals 3f of x plus 2g of x. So some questions to ponder when you do this problem is, what are some good values to pick for x? All right. Are there any problematic values? Are there any values that if you pick for x, you still have multiple answers remaining? And then one last question is, what is the school way? How long would the school way take? All right. So there are things I want you to think about. So to recap today, we are picking our own values, right? The values that we pick have to work for that particular problem, and they should be the easiest values for you for that problem. Values that you pick may be different than values that another person picks. So you are going to get different answers as far as the numerical value you get for the problem. But then when you plug in your respective values to the answer choices, you will all end up at the same answer. Right? So it's really important to pick numbers that make sense to you. If you pick numbers and you have multiple answers remaining, it means you need to pick new numbers. All right? And these are not very good for solving equations. If you have to just solve an equation or a system of equations, that just has one answer and you're not just going to pick it. That will be best to just solve it using the school way, or go back to episode 1 and kind of see how we were doing it by plugging in the answer choices. All right. So this is when you go into a problem, you pick your own values, as opposed to episode 1 was where you would use the answer choices to plug in. Very similar, both very powerful strategies. But again, as we've been saying this whole time, there are times to use it, and then there are other times when you don't want to use it. So that's it for episode 2. Please like us below, subscribe to our YouTube channel if you haven't done so already. Make sure to follow us on Instagram, Twitter, and Facebook. And until next time, your friendly math tutor is out. Scratch that. I equals, man. So we're just going to start over with I just screwed up again. Scratch that.